Okay, folks, we're going to go over the 2015 number 5 non-calculator question. Once again, it's going to involve working with number line graphs. So we're going to see what number lines are going to help us find about an original graph. So we're starting out. The figure above shows a graph of f prime. We know that the values of this graph are f prime, and we know that the second derivative of the graph is the slopes. And that would mean the values of f are based on the integral of f prime, meaning f is the area under the curve. Now they tell me there's horizontal tangent lines, and I can see them at -1, 1, and 3. And they've given me some areas of some regions. And they're kind of trying to trick me here. They tell me this area is 9, but I know it's really -9. And this area is -12. So the first thing they ask me to find are all the x-coordinates at which f has a relative maximum. I'm here in maximum. I'm going to write to a number line graph. So the values of this graph are f prime. Is there anywhere where the value of this graph is 0? And the answer is at -2, 1, and 4. -2, 1, and 4, the value of the graph is 0. Now the values in between those intervals, the values are positive, then negative, then negative. So that means our graph is increasing, decreasing, decreasing. So does it have a max? It has a max here. So for justification of my answer, I can write yes. Max at x equals -2. I could even, it's usually enough, let's put a little more, you can even write C chart. But the word reasoning you can put down is f prime at -2. Oh, hold on, let me write that a little better. At -2 is 0 and changes from positive to negative. And that's enough of a verification for what's going on there. Next it asks, on one open intervals, is the graph both concave down and decreasing? Well, concavity is going to come from the second derivative. So I'm going to make another number line graph. F double prime. F double prime is the slopes of this graph. Where is the slope equal to 0? That would be at -1, at 1, and at 3. 0. The slopes before and after are negative, positive, negative, positive. That means our concavity of our f graph is down, up, down, up. So they want to know where it's both concave down and decreasing. Well, my explanation is that f prime is negative and f double prime is negative between, well, where is that true for both? I'm looking at this graph here. It's negative and decreasing. Sorry, it's decreasing and concave down in this interval between 0 and -1. That's not -0, -1, sorry. Between -2 and -1. Also, concave down and decreasing in this range. I'm running out of room there. I'm going to write it up here, sorry. Also between 1 and 3. They're not picky on how you write the words out anyway is fine, but the reasoning for it is this right here. The first derivative is negative, and the second derivative is negative. That's why that information happens there. Find all the x-coordinates of points of inflection and give a reason. Well, I have it on the graph right here. I've got -1, comma 1, comma 3. And as a simplest explanation, I could just go C graph and point to the number line graph. But that's not always enough for me. I always need a little bit more. So I would then add in is at f double prime equals 0 and changes sign. I can write that for changing concavity because changing concavity is just a change in sign. When they asked me about a maximum, I had to say that it went from positive to negative. Otherwise, if I say it just changed sign, it might be a minimum. And that's not what we're looking for here. And so I filled this page pretty good. So let's go look at the last part, which is always the trickiest part. It says, given that f1 is equal to 3, write an expression that involves an integral. I'm going to not worry about this to begin with. They want me to find f of 4 and f of negative 2. Well, I know that f is equal to the area under the curve on this graph. And I already know that this one is negative 9, and this one is negative 12. So I'm going to make a table of values for f of x. And they gave me one value. They told me when x is 1, y is 3. Okay, so that means if I want to find when x is 4, I have to find the area under this curve and add it on up, add it in. So it goes to negative 12. So if I start at 3 and I go negative 12 steps, I end up at negative 9. So now we have to think about the going backwards because they want me to find it at negative 2. So if I start at negative 2, I'm going to write it an integral for a minute. If I start at negative 2 and I go all the way to 1, I know I will have gone negative 9 steps. So we're going to do, because we're going backwards, we're going to do the opposite of what it says to do. So instead of subtracting 9 from the problem, I'm going to add 9 on, and I'm going to get that this is 12. And then I'm going to test it all to see if it makes sense. If I start at negative 2, I'm at 12. If I subtract 9, I end up at 3. If I then subtract 12, I end up at negative 9. So that's the correct answer for the problem. The way they want you to think about it is you want to combine these things on like so. I'll show you. You know that if you have, if you're looking for f of 4, that's going to be the same as f of 1 plus the area under the curve, or the integral from 1 to 4 of f of x dx. And now let's do it the other way. If we have negative 2, f of negative 2, what did we do? We didn't add the integral on, we subtracted it. It's equal to f of 1 minus the integral from negative 2 to 1 of f of x dx. I wouldn't worry about this. It takes a lot of thought for that one little point. But the rest is always, when you're looking to find values, you just count the area and either go forward or backward. Okay, there's our next video. Talk to you soon.